So why don't we go ahead and calculate the standard deviation for the following sample scores of a 15-point quiz. So the first thing I need to do is calculate the mean. Notice I don't have to rearrange or sort these scores because I'm worried about the mean, which is the average, not the median or the mode. An important thing to note might be how many data samples I have. I have 1, 2, 3, 4, 5, 6, 7, 8. So my N in this case, my sample size, is 8. So the first thing I'm going to do is calculate the mean. We call that X bar. Let's start to get used to some of this notation. That's 10 plus 9 plus 13 plus 12. I'm sure you guys love me just saying numbers over and over again. Plus 11 plus 7 plus 14 plus 15, all divided by my sample size, which is 8. So I get a mean of 11.375. I'm going to round that for simplicity to 11.4. Okay, the next thing I have to do is I have to calculate the deviations. So I have to take each data value minus the mean. So I'm going to take 10 minus 11.4 and I get negative 1.4. I'm going to take 9 minus 11.4 and I get negative 2.4. 13 minus 11.4, I get a positive 1.6. 12 minus 11.4, I get a positive 0.6. I'm going to have to make another column. 11 minus 11.4, I get a negative 0.4. 7 minus 11.4, I get a negative 4.4. Oof. 14 minus 11.4, I get a 2.6. And 15 minus 11.4, I get 3.6. So that was step 2. Step 3, and you could not do these each broken down step by step. You could take the difference and square them right away, but I'm going to break it down really slowly so we all get really comfortable with it. So now I take each of these squared, and I'm going to go ahead and take the sum as I square them, right, because we're going to square the sums. So negative 1.4 squared, so this is really steps 3 and 4, plus negative 2.4 squared plus 1.6 squared. Notice I'm using parentheses. It just makes sure that that negative is included when I square it. Your calculator will thank you, so will I. Plus 0.6 squared plus negative 0.4 squared plus, we gotta start a second row, negative 0.44 squared plus 2.6 squared plus 3.6 squared, and I add that all up and I get a sum of 65.72. My next step is to take the square root of 65.72, so this is step, I guess, 5 and 6, divided by 7. That's going to be the square root of 9.388 dot 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 dot, which is 3.064, or about 3.1. So this is our standard deviation. So let's talk about how in this course we're going to estimate the standard deviation. We're going to use the rule of thumb. So the standard deviation is approximately related to the range of a distribution using this range rule of thumb. Note, the bigger the sample, the closer this is to the true standard deviation. So what we're going to do is we're going to take a range divided by 4. And it's also kind of crucial that there aren't a lot of outliers. So no outliers. That's going to be our standard deviation in this course, except for the couple homework examples where you will have to solve it by hand. After that, we're just going to use range divided by 4, or the standard deviation will be given to you, which is really nice. So why don't we go ahead and use this rule of thumb. Remember that range is the highest value minus the lowest value, and estimate the standard deviation for those two quiz scores sets we looked at. So remember in example 5, we found, that's the example I worked out entirely, we had 4 quiz scores and we found a data set of 3.096. And in example 6, we had 8 quiz scores, and we found a standard deviation of 3.064. So what I'm going to do is I'm going to take my rule of thumb, which is the range divided by 4. So I'm going to take 15, which is my highest value, minus 8, and find my range. So I get 7 divided by 4, which is about 1.75. So we would be using that. Now that's not quite close to our standard deviation, right? But it is a good guess, a good estimate. Now let's try this for our example 6. I'm going to take my range divided by 4. That's 15 minus 7 divided by 4. That gives me 8 divided by 4, which is 2. So our rule of thumb, standard deviation, this is a little bit closer to the actual standard deviation, would be 2. So alternatively, if we know our standard deviation, even through the rule of thumb, we can use this rule to estimate the high and low values as follows. So this would be values that we would consider to be really close to the mean. They'd be within 2 standard deviations. We're going to talk about this more in chapters 5 and 6. But just so we know right now, we can use the standard deviation to estimate our lowest possible data values, the lowest value of our range, which would be mean minus 2 times the standard deviation. And we can also use this to estimate our high value. That would be mean plus 2 times the standard deviation. So typical data values that we see, things that are not outliers, are always within 2 standard deviations of our mean. Something to keep in mind as we move forward. So important to note again, range rule of thumb does not work well with outliers. So studies of the gas mileage of a Prius under varying driving conditions show that it gets a mean of 45 miles per gallon with a standard deviation of 4 miles per gallon. Let's estimate the minimum and maximum typical gas mileage amount that a Prius owner can expect under ordinary driving conditions. I don't own a Prius. But this was a useful example to see how much gas mileage you could expect to get. So let's calculate our minimum. That's going to be our range minus 2 times my standard deviation. So I've got, not our range, our mean minus 2 times our standard deviation. So I have 45 minus 2 times 4. 45 minus 8 gives me 37. So that's going to be our lowest possible mileage we could expect. And then our maximum, that's going to be our mean plus 2 times our standard deviation, which at this time we're representing with S. So I've got 45 plus 2 times 4, that's 45 plus 8, which is 53. So we could expect our car, our Prius, under typical driving conditions to get between 37 and 53 miles per gallon.